Hello, hello all. Welcome to Lazy Ninja BAS. Today we are going to discuss about hardware engineering and log inputs. We will look at how selection of sensors are made in different verticals and different types of sensors, signals, and its application. HVAC usually consists of units which circulates air and water in a closed loop. To control the air and water circulating with required conditions, we will define the controlling parameters with inputs being received. We will be looking at possible analog inputs in this video. We will see the design criteria to choose appropriate sensors according to the applications. Majorly, analog inputs will record temperature, humidity, pressure, indoor air quality, flow. Selection of sensors will be based on specifications of the jobs for the verticals and applications we are using. Let's start with temperature sensors. You will measure temperatures of air, water, steam, refrigerant. Temperatures will be measured in ducts, pipe, or it can be wall mounted. Sensors are different types or can be made of different types. It can be thermocouple or the thermistors, which are RTDs. We will usually be using thermistors. Generally, we use NTC 20K or PT1000, but there are different other sensors which can be used. There's NTC 10K, PT100, or PT10K. All these sensors will be measured with a resistance chart. All sensors have temperature to resistance curve. Few sensors can provide voltage and current signals, which is 0 to 10, maybe 2 to 10, or 4 to 20 milliamps. And these can be characterized or will be characterized from the factory being 0 volt to minus 58 degree Fahrenheit or 58 degree Fahrenheit to 302 degree Fahrenheit or however the resistance curve goes. That's based on who manufactures it. Every manufacturer has or can have their own resistance curve, resistance to temperature curve. Duct sensors or wall sensor are easily mountable. All you have to do is drill a hole, put the sensors in, and screw it up. However, wet temperature sensors, these should have a thermowell installation where your actual sensor goes in the thermowell and gets tied in. Now, here are the selection process for your sensors. If your temperature sensors is a ducted one, based on what do you guys decide which sensor has to be used? So duct sensors are usually based on how much the duct length is, or say if you guys are using an average sensor, it can be however the unit size is. So the temperature sensors used in the unit are always averaging sensors in the most of the cases. These sensors are widespread throughout the coil surface to know the airflow temperature through the unit. So it can be either on the duct, depending on the duct size, or in the unit based on what applications you're using with this. So based on how much the duct length is, you might have to appropriately consider the length of the temperature probe which you're inserting in. Now, when it comes to wall temperature sensors, there are a whole new types. There can be temperature sensors with the display. There can be temperature sensors without the display. Now, there can be temperature sensors with display and the set point, which you can manually change from the buttons or from the knob, Well, there you go. There are two other differences only in the set points. You can either use it through knob, either from buttons. However, it is based on your specification or your custom needs. It all boils down to that. Apart from that, say you guys have temperature sensors where nobody has to know where it is placed at, or it has to be flat mounted. It should not come out of the wall surface. You can use a plated temperature sensor that just goes slapped into the wall surface, doesn't come out of the wall surface. And these are mainly used somewhere uh, in the kitchen or wherever you guys have like an auditorium or somewhere you guys have fancy walls, which something popping out of the wall is like a architectural flaw to them. So you can use these things on that. Now, apart from that, you can have combinational sensors, which are temperature sensor with a humidity, temperature sensor with a CO2, or temperature sensor with humidity and CO2 both. So these are the different types of all the temperature sensors which you can use or which generally are used. But apart from these things, there are still a lot many different temperature sensors which you could have come across or you will come across. But these are the usually ones which we use in the commercial projects or the other projects we will be concerned about. Coming to humidity. Let's go to humidity. Now, the humidity sensor, as the same, it can be a duct mounted or wall mounted. And the signal type for the humidity sensors will be either 0 to 10, a voltage signal, 2 to 10, a voltage signal, or 4 to 20 milliamps, which is a current signal. Now, the selection process for the humidity sensors in major cases, so if the humidity sensors, if you guys are using it for the commercial purpose, you might not have to go through a whole lot of specs or how it is built. All they care about is if the humidity is within their range. So it doesn't really have to boil down to what its accuracy is, what the specs calls for. So the humidity plays a very important role in the pharmaceuticals. If you guys are working in a pharmaceutical, selecting a humidity sensor, then you might have to have a precision or the accuracy which is mentioned in their specification. Humidity can have or give you an accuracy of plus or 2%, plus or 3, plus or minus 3%, all of that. So you might have to look closely into a specification, what the customer needs, what type of sensor he needs in the humidity, and what his precision has to be with humidity sensors while they are selecting. That is all about humidity sensors. Let's move on to pressure sensor. What other types of pressure sensors can you have? Pressure sensors can also be duct mounted, wall mounted, panel mounted, which is more or less the same as wall mounted. The sensors will be recording the static duct pressure if it is mounted in duct. The sensors can record the differential pressure between two rooms. The sensors can record the overall building pressure with respect to the atmosphere. In some cases, the duct static pressure will be used to measure the flow through the duct. And I'm not saying this is the appropriate way to use it, but it can be used. And this is how I've seen in my retrofit jobs. What they've done is the same duct static pressure coming from an outside air duct being used as an outside air flow. So the calculation for that, you might have to go through what your duct size is, what duct static pressure you're getting, and you can calculate the flow coming in. That's pretty much it on the duct static pressures. Now, the pressure sensors usually, even if it is a duct static pressure, or even if it is a duct mounted, wall mounted, or a panel mounted, it's all still the same. All the pressure sensors will have a low tube and a high tube. What you measure is whichever the whichever side the airflow is, the side of the airflow coming in will be the higher pressure, and the one which is going out is the lower pressure. So whenever you measure, it is either high or low, depending on what you want to see. So if you want to see a building pressure, you will connect your high probe on the building side and the low probe to the atmosphere, so that whatever pressure you get, that's the positive pressure maintained within the building to outside of the atmosphere. Hope this is all making sense. So let's move on. When pressure sensors are usually used, the signal type preferred is current signal, which is 4 to 20 milliamps. The reason we use current signal is duct static pressure sensor, which is preferred to be in two-thirds of the duct coming from the unit. The long run of the wire from the sensor to the controller will add resistance to the signal input if we are using a voltage input, thereby hampering the pressure readings recording at the controller. The wall-mounted pressure sensors are very critical in pharmaceutical applications. Basically, pharmaceutical needs positively pressurized corridor and less pressurized material or the main room and even lesser pressurized production areas. The reason to this is production areas won't have the same product in adjacent areas. To avoid blending two products and contain the product within the area, pressurization is very critical. Temperature and humidity plan acts an important role for production as well. Specific products need specific requirements of temperature and humidity with utmost precision. Now, temperature and humidity come with specific accuracy. There are combinational sensors and monitors which are most often called clean room monitor. These are monitors which shows the temperature, humidity, and the pressure in the production area. So if one of these things go out of the limit, they can be wired to a buzzer or a siren or a strobe which says, hey, you guys are out of the environment where you can have your product to be manufactured. So you probably have to stop there. And this is how usually it goes. The clean room monitors they are fitted into a strobe or a horn which says, hey, you guys don't have a preferable environment or an ambience where you can have these products manufactured. And they'll have to record all of these and stop the manufacturing there. In the major cases, all these clean room monitors, they can be daisy chained and communicated over protocols. It can be BACnet, it can be Modbus. All of these data will be recorded back into the front end where a BMS guy or a BMS will accommodate all the trends and histories of what is going on in what production areas and all other data of the sensors being depicting all its temperature, humidity, and the pressure of that certain area. All of these will be recorded and documented in the same way. Documentation is key in when it comes to pharmaceutical operations. Now, the selection process for the pressures will be pressure sensors need accessories such as pickup tubes, metallic bends to get the reference of the pressure difference. So will have a high and a low tube, but where do you pick up the high and low tube from air? You'll need pickup tubes. When it comes to wet pressure differential sensors, you will need to have the pickup tubes not to get air, but to get water. So it will be metallic fit out tubes going into the sensors. So there will be pickup tubes in different accessories. Say it has to go in the duct. You can't just place a straight tube in the duct. You'll have to measure the airflow, the side of the air which is flowing through. So you might have to have a metallic band where it picks up on a L band where the airflow is coming in. So these are the different other types of pressure sensors depending on what applications you're using. You might have to select the accessories required for certain or respective applications. Or air quality sensors. The indoor air quality sensors record concentration of multiple gases present in the air, which can be carbon monoxide, carbon dioxide, nitrogen dioxide, or any other gases. The majorly uh, use of these indoor air quality sensors are in garage ventilation, where we have carbon monoxide and nitrogen dioxide emitting out of our vehicles. The sensors will be placed to cover certain radius of the garage space throughout the garage. These sensors will communicate over a daisy chain with a backnet or Modbus coming back to your controller to communicate the signals, or it can be a current signal coming back from individual sensors, or all of these can communicate over a Wi-Fi mesh network and then communicate back to your controller where you record all the data. Depending on how your job site is, if you can pull more and more wires, you'll take the current signals, but your labor charge of pulling wires may be higher than the actual sensors and the job itself. And you might have to go to having a daisy chain with all of these things communicating over a single loop of BACnet or Modbus. So depending on how you want to design the job or how much you have the cost, how much you want to spend to this application, you will have to design or you will have to select these sensors, where to place them, how do you want to wire these, and then get it to your controller to recognize how much of the concentration you're getting in the garage space. The usual applications for these is whenever there is a spike in the concentration of the gas, the controllers will energize the circulation fans where it brings in fresh air and takes out the existing air through the exhaust fans. So that's as simple as that. For these air quality sensors, all they do is maintain a certain level of concentration should so that there is always fresh air passing through and shouldn't create any hazards. Looking at the other types of sensors we have, let's move on to flow meters. Now, there are few different types of airflow measurement and water flow measurement sensors, or should say meters. Airflow measurement can be a ducted airflow measurement with the probes, a fan discharge measurement, or a fan inlet measurement. So the probes which you insert to measure the airflow will have tiny holes which measures the intake and calculate the differential pressure, which in turn would calculate the whole flow coming back to the meters, and the meter will give you an output which can be a voltage signal and a current signal again. It can be a backnet, it can be 0 to 10, it can be 4 to 20 milliamps, whatever you need. So the probes connecting throughout the duct length will be based on how large your duct is. Say your duct is 2 by 2 feet, you probably will have two probes connect, fitted on the horizontal lines and two probes fitted on the vertical lines. So that's how the number of sensors which you fit is, or the number of probes which you take is usually calculated. There is a chart where you can go and see how much the length of your duct is, how many probes you need. I usually go through the Eptron flow measurements or flow meters, and I usually go through this chart to see how many sensors I need, what is the model of the flow measurement meters which I would require for this particular application, and select that. That's as simple as that. Coming to the fan discharge and fan inlet, it's still the same. Only that you don't have to select the probe and this thing depending on the diameter or the circumference of your fan inlet or the fan discharge. There are accessories which you will get to record the airflow coming or pushed from the fan and goes back to the board where you again get back the measurement of your airflow on a voltage or current signal or probably a communication protocol. The same thing goes while you're measuring the water flow as well. The water flow measurement can be of, again, different types. It can be a turbine flow meter, electromagnetic flow meter, or ultrasonic flow meter. A turbine flow meter will have a tiny wheel. As your water flows, the tiny wheel keeps spinning and gives you, based on its own calculation or the calibrated calculation of how speed the tube or the turbine was spinning, so as to measure how much the flow was. It can be the electromagnetic, which will still be inserted inside the pipe, and it is based on not on the turbine rotation, but on the electromagnetic pulse. So these are all calibrated from the factory and then given back to the board, which is given from the factory as well. So all we as a control contractor, all we get is a 0 to 10 signal or a 4 to 20 signal from the board. Now, the only selection process for these things are, say, when you guys have a mechanical drawing with you and the specification with you, you will have to be very careful on to see or to coordinate with the field guys to see what type of piping are they doing at the site. If, if at all, if the piping they are doing is an aquathermal pipe, you cannot use the turbine or the electromagnetic flow because the aquathermal pipe cannot have a drill down the pipe and have these things inserted. For the aquathermal pipe, you probably would have to use an ultrasonic flow meter, which do not require any drills or any fit outs where your sensor has to be placed. These things can be placed outside of the pipe, just at the diameters of the pipes, and they can give you the flow of how much the water is flowing or the liquid or the fluid is flowing. So water flow will be recorded from the insertion flow meters or ultrasonic, which will feed the board with frequency pulses and calculate the flow output. That's the major criteria what we have here, and that's pretty much it on the flow meters. These are the major categories of sensors we deal in almost every jobs we execute. Thanks for watching the video. Hope you guys liked it. Please comment below of what you think of it or if you have to provide any inputs. Stay tuned for my next video discussing about analog outputs, binary inputs, and binary outputs. Thank you guys. Cheers.